Okay, for the group case solution, and the information from the question that we get is U prime S for the block is 0.5 here at this here the friction coefficient there US 0.4 then force gravity angle is B here to here. The C is from end of the block to the down here, and for F the distance from this to C.
FBD, we will be using point 1. Alright, so we have a force towards negative x-axis, and that force is valued at 300 Newton. And we have two tensions having an angle of 60. So from this FBD, we can deduce that submission of x component equals to 0, and so you have P as negative, and you have two tensions, and you get this, and you substitute the values, and you get tension as 173.21 newtons.
For FBD2, we are going to find the FB and the NB. How we're going to do it is when we find the moment at point C by equating it equal to 0. So we're going to use this and this. In this formula, we're going to equate all the forces in a way, and we'll make it equal to 0. And then we're going to use another equation, which we will say that FB here is equal to 0.5, and 0.5 is the friction coefficient, to NB. When we substitute this relationship into the first formula, into the first equation, we are going to solve for NB and FB in this manner.
Okay, so this is the FBD for the third point. This is the body, and these are all the forces acting on this body. So we want to solve to get the M. So we'll take in terms of x-axis first. So in x-axis, there's F ground and 2FB. And then when you solve it, you'll get 215.32 Newton. Then for Fy, we have N ground acting upwards and W acting downwards. So we'll have N ground minus W minus mg equals to 0. Mg, when you solve it, you'll get F ground over mu times the gravity. As we know, F ground is equals to mu times N ground. And then we can substitute the value of F ground from this, which is 215.32 divided by 0.4, the mu times 9.81. And then you will finally get the mass, which is 54.8 kgs.